Okay, let's begin. Right, but I want this to be interactive. So promise me that you, if you are not contributing, you will mute your mic so that we don't pick your background. Otherwise, as a tutorial, it will be very difficult. I'm not presenting a lecture, so I want it to be as interactive as possible. So, if you do not comply, I think I can dismiss you from the meeting. So I'll unmute you and allow you to, you can unmute yourselves. I think I've given you the permission to unmute yourselves. So you would unmute yourself if you want to participate because it's a tutorial, and you can raise your hand if you want to contribute. Are we together?
Yes, ma'am.
Okay, so let's begin. We want to look at question A2, which is giving us a bivariate, right? It's a bivariate data set with variables x1 and x2. So we are saying if we look at this data set, this is more like the observation from member number 1, where we have their value for variable 1 and their value for variable 2. So our sample is 10 observations. Now, looking at checking normality, we say it's multivariate normality can be checked in 2 ways. One way is to check each of the variables if it follows a normal distribution. And then with that, we can loosely attach it to multivariate normal distribution. So we are saying if x1 follows a normal distribution, univariate, x2 follows a univariate normal distribution, it gives an indication of multivariate normality, but not directly, not as such, but we are saying whenever we will be happy if all the variables follow a univariate normal distribution, because that would more like, but it's not a direct implication that if while all the variables follow a univariate normal distribution, each variable follows a univariate, then as a joint thing, they follow a multivariate. But the other way around is true. If you have a multivariate normal distribution, that automatically implies that x1 follows a multivariate x2, each of the components. So here we want to look at one way of showing multivariate or implying multivariate normality, which is doing MAQQ plots. What are we expecting from MAQQ plots? We expect that if we plot these values, they observed. So if you look at this, this is our observed, these are our observed values for x1 versus the quantiles, if we assume that these follow a normal distribution. So versus the quantiles corresponding to the probabilities or cumulative probabilities, then we can, if we plot these values against those quantiles, then we can assume that it's multivariate normal. So the starting point, I'll be using this page. I'm not sure if you can see if I'm sharing with you a blank page, which is a blank file, which is, so I'll be toggling between the two tabs. The one that is our questions, and the one where I'll be trying to illustrate some of the things. Unfortunately, I couldn't do that beforehand, so I will try to illustrate by writing on this thing. So I will try to draw.
Oh,
Pakanaka. So looking at our question, So can you see, am I sharing HSTS 215 tutorial 29 June, which is just a blank page where I'm hovering my pen there?
Yes.
It's okay. If it's shared, that's fine. So your starting point, if you look at the outline which I gave you on doing how to perform my QQ plots manually and how to perform my chi-square manually. The first thing is to rank your observations, right? So if we look at, let's try X1. So our observations are 3, 5, 5, 7, 6, 7, 8, 9, 10, 11. And we can see repeated values. For example, when 5 are occurring twice, bana 7 are occurring twice. So on ranking them, ranking, you understand it's two ways of ranking. You either rank in ascending order or in descending order, starting from the smallest. That's the natural way of ranking. So you can do that in the form of a table. So for example, here I can create a table in my order. So the smallest, this is more like your eye. The smallest, 2, 3, pardon me for the handwriting because I'm just using mouse here, the keypad, the touchpad. Saka is not coming out nice, but I hope it will do for the sake of illustrating. So that's the order. When you write, when you observe my values, we say Tine XI as your observation. So if you look at this is X1, this is X2, this is X3, this is X4, this is X5, this is X6, X7, X8. We are saying the value that I observed or that I recorded at this particular position. But now, when you look at, you cover this, I'm not sure which other course covers ordered statistics. When you put my brackets per subscript like that, this is saying it's an ordered. So these are ordered statistics. So if I say X1, I'm saying the smallest of the observation. But when I'm saying X1 like that, I'm saying that's the first observation in my sample. So in this case, this 3 is X1 without brackets, and it also happens to be the smallest. But maybe you shall see for some that xi without brackets and xi in brackets would be this different. So that's the notation. This is an ordered statistic. So I'm saying x, if I say x7, I'm saying if I put the observations in ascending order, this is the value that is sitting on the 7th position. What is the value? So here I have my xi, right? I will put it as xi. So the smallest value, if we look at your smallest value, is 3 followed by 5, followed by 6, 7, 8, 9, 10, and 11. So it's 3, 5, 7, 3, 5, 6, 7, 8, 9, and 11, 10, and 11. So the smallest is 3, 5, 6, 7, 8, 9, 10, and 11. So here, as you can see, we have 10 observations, which means what happened or what you can pick from this, we have some repeated values. So we'll reflect them on writing the cumulative frequencies or on writing the frequencies. So to make it easy for you, you can maybe put a column for right, let me switch off this thing. Sorry about that. So you can put a column for frequencies. So if you look at the 3s, we have 1, 5s, we have 2, 7s, we have 2, and the rest are 1, 1 each. Right, so here, 5s, we have 2, 1, 2, 1, 1, 1, 1. Right, and then the next column, you want to write the cumulative probability. So the cumulative probability, that's the probability that x is less than xi, less or equal to xi. So in this case, we are looking at that, the ordered statistics. So that's the cumulative probability. The way we find the cumulative probability, how many observations are less or equal to the value over the sample size. So our sample size is 10. So we are dividing by 10 the cumulative probability, the cumulative frequencies. So in this case, we are not looking at the cumulative probabilities straight. So let me remove some of these things. So in this case, we are not looking at the cumulative probability direct, but we are looking at, we have to put a continuity correction, because when you look at these are discrete and we want to treat it as a continuous variable. So here, we instead, the proxy of this cumulative probability is I minus, sorry, it's I minus, right, so it's I minus half over n. So all that over n. So we subtract a half from the continuity correction from the cumulative probability. Now this I, the way maybe I'm explaining it would be confusing, but we want the cumulative frequency to represent the I. This will be ideal, but not two or multiple frequencies for a particular value. So that's how you find it in the in Johnson. It's the cumulative frequency for a value minus half. So more like the continuity correction on the cumulative frequency divided by n. So that will give us that probability which we want. So in this case, we are saying cumulative frequency is 1 minus half is half over 10. So we are looking at 0.025 is the probability we want there. Here, the cumulative frequency will be 1 plus 2, which is 3 minus half over minus half, so it's 2.5 over n. So it will be, sorry, this would be 0.05, not 0.025, 0.05. So it's half over that. This one will be 0.025, 0.25, 0.25. This one will be, cumulative frequency will be plus 1, which is 4 minus 1 minus half, 0.35, and 6, 0.55 for this one, 0.65 for this one, 0.75, 0.85, 0.95. Right, so that's that. Now, we now want to find QI, right? QI, sort of like quantiles. So our meeting will be disrupted in about 10 minutes because this is not a licensed version. So anticipate that, but I think thereafter we can just reconnect. So we now want to find the quantiles, more like from a standard normal, what value would have its cumulative probability is this? What value would have its cumulative probability is that? So going on the normal tables, right? From the normal tables, you now read off from the statistical tables. So if you look at the standard normal distribution, right, under 0.05, the value which is its cumulative probability is 0.05 will be minus 1.645, 1.645. So basically we are saying, if you look at the normal distribution, right, we are saying these are the probabilities that are on this tail. So we are looking at the Z scores or Z values, which will leave 0.05 on the left tail, 0.25 on the left tail, 0.35 on the left tail, 0.55 on the left tail, and so on. So you will find this is my 1.645, and I think on this one, since it's symmetric, we know that this will be 1.645, the positive value, and the other values are in between there. This will be closer to 0. Unfortunately, because I don't have my table, I did not work that beforehand. So I think you can work your way out. You can also do that in Excel. There is a way of finding the probabilities. You can do that in R. There is a way of finding the quantiles. I think the Q norm, you can use the Q norm, you specify the probability, you specify the standard deviation, which is the standard deviation, which is 1, the mean, which is 0. So you find these probabilities. And then we now, after finding these probabilities, you now plot, right? So on one side, you have your xi values, the ones on the ones that are in this column, versus the qi. You can put it the other way around, but whatever we are looking for would be whatever you can deduce the same thing whether you put qi on the horizontal or on the vertical. So here you plot qi. So what we expect, right? If it's a normal, if your values follow a normal distribution, we expect that this plot, the scatter plot, or the line plot, whatever you can make it, should be more of a straight line. We are looking for a straight line. So it will be showing that these values we observed here, there is a one-to-one matching. So a straight line is indicating more like they share the same distribution. So if these values follow a normal distribution, we expect that the plot, the scatter plot of these values versus the ones where we are assuming a normal distribution should be in a straight line, right? So that's the first part. Now I will allow you to ask questions regarding this procedure. So I think I've given you the guidelines of how you do it, right? So any questions so far on the QQ plot, the manual way? Questions? Ed?
Pronunciation. Pana QI pa hata hapa nilichenda normal table yangu then nichienda pana 0.05
unoenda not under z apa tiri kutsvaga if you are using the statistical table redu the book uri kuenda mukati because my probabilities are the values dziri mukati if you remember statistical table redu kuti rakamira sei. We have left a column. All right, Velapi, I will attend to you. Right, to left, we have a column in a z values. Here, we want to find my z values. These are z values. My QIs are z values. They are quantiles. But now 0.05, my probabilities. So you are looking from my values and usually it needs a linear interpolation to get the z value because it's not they are not you would not get exact values. But if you are using maybe Excel, let me illustrate in Excel. Okay, maybe let me illustrate in R. R would be easier. Right, let me share the screen here, R. Then Velapi, right, Velapi, can you launch your question maybe in address one?
Okay, the first question is, we have J observations. I think our observations are represented by J, but on our table we used the I don't know why. And the next question is where we find the probabilities X less or equal to X subscript I in bracket. The formula you said I minus half over N. On our N, are we using 10 or we are using 8?
We are using 10. N is the sample size. The choice of I and J is arbitrary. Indexing, I can use K, I can use I. Rimebuku would use I, Rimebuku would use J. But the choice of for the indexing letter is arbitrary. And then your N is your sample size.
Okay, so we are taking those components, I components 1, 2, 3, up to 8. Then we'll be subtracting half, then divided all by total number of observations, that is 10.
Right, that's the explain and the it's sort of like a bit tricky here because Panama values are more than one. This I there would be your cumulative, maybe, I'm not sure, maybe in such answer I, it's your cumulative. If you look at 3, how many observations are less or equal to 3? 1 out of 1 minus, for 3 it coincides I in a cumulative probability. But when we come to this one, I is 2, I is 2, or maybe, I'm not sure, but when you look at the cumulative probability, it's 3. So 3 minus half. Rather than having per position 2 pana 5, per position 3 pana 5, it's confusing that way. So if you maybe maybe so let's put a column. All right, let's put a column yet not cumulative freak free FC. Right, so it's some accumulative frequencies, and then pana apatova that FC rather than using I.
Okay.
So that apparent confusion. But when you put these values as ordered statistics, this is the first smallest, second smallest, third smallest. I can't talk of my cumulative probabilities because Panama tight observations. The tricky part is being brought into the equation. Tight observations. So maybe let's put an FC Panapa so that we don't mix things.
Okay.
Right. So it will be 1, 3, 4, 4.
Okay.
Then 6.
We are adding the first.
And it cumulative probability, you are saying this values that are less